In this episode, we are taking up a topic that sits very close to the heart of auditing, risk reduction, and dependable system operation, even though it can sound a little abstract the first time you hear it. Control identification and design are about figuring out where an organization needs protection, oversight, or verification, and then creating measures that actually work in the real world instead of only looking good in a policy document. For a beginner, the simplest way to picture a control is as a deliberate check, barrier, or safeguard that helps keep people, processes, data, and systems from drifting into error, misuse, fraud, or failure. Some controls stop bad things from happening. Some reveal that something has already gone wrong, and some help the organization recover when trouble appears anyway. The reason this topic matters so much is that organizations rarely fail because they had no technology at all. They fail because important work was happening without the right guardrails, or because the guardrails that existed were weak, misplaced, poorly designed, or never truly followed. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A control is not limited to one kind of activity, and that is worth understanding early because many new learners assume controls are always technical settings inside software or security tools. In practice, a control can be a manager approval before money is released, a system rule that rejects invalid data, a review of user access, a reconciliation between two reports, a locked server room, a background check, or a separation of duties that prevents one person from doing too much alone. Control identification is the work of spotting where those safeguards are needed. Control design is the work of deciding how the safeguard should function, who should perform it, how often it should happen, what evidence it should create, and what should happen if the control reveals a problem. These are connected activities, but they are not the same. An organization may identify a real risk and still respond with a weak design, just as it may build a beautifully documented control in a place where the real problem lies somewhere else entirely. The best starting point for identifying controls is not a favorite security feature, a popular checklist, or a template copied from another company. The best starting point is always the business objective and the risks surrounding that objective. If a payroll process must pay employees accurately and on time, then the first question is what could prevent that result, such as unauthorized changes, calculation errors, missing approvals, system failures, or duplicate payments. If a customer portal must protect private data while remaining available to users, then the next question becomes what could expose that data or interrupt service. Controls become much easier to identify when the organization first understands what it is trying to achieve and what could go wrong along the path. Without that grounding, teams often install controls that are visible but not especially useful. Good control work begins with purpose, because controls exist to support dependable outcomes, not merely to satisfy a vague desire to appear careful. That focus on purpose usually leads into process understanding, because risks do not float in the air by themselves. They appear at specific moments inside actual work. To identify controls well, an organization has to understand how a process starts, what information enters it, who touches that information, what decisions are made, what systems are involved, where approvals occur, where handoffs happen, and what the final output is supposed to look like. A purchase process, for example, may involve a requester, a manager, a finance reviewer, a vendor system, and a payment platform, each creating different opportunities for error or abuse. If the organization only looks at the last step, it may miss the fact that the real weakness begins much earlier, when requests are submitted without enough review or when vendor details can be changed too easily. Process walkthroughs, data flow understanding, and careful attention to dependencies all help reveal where controls belong. Identification is much stronger when the team sees the full path of the work instead of only the most visible point where failure might finally become obvious. Once the process and the risks are visible, the next step is defining the control objective clearly. A control objective is the specific result the organization wants the control to achieve, such as ensuring only authorized changes are made, ensuring transactions are complete and accurate, ensuring sensitive data is available only to approved users, or ensuring exceptions are detected quickly enough to matter. This matters because a poorly defined objective produces vague controls that people cannot evaluate properly. Saying that a process needs better oversight is too broad to guide good design. But saying that all vendor banking changes must be independently verified before payment instructions are updated is much more useful. Clear control objectives also help teams avoid the common mistake of jumping straight to a solution without first agreeing on what the solution is supposed to accomplish. From an audit perspective, this is important because you cannot judge whether a control is effective if nobody can clearly state what it was designed to protect, confirm, restrict, or reveal. Good design begins when the organization can answer the simple but powerful question of what exactly this control must help us achieve. Many learners find it helpful to organize controls by what they are meant to do, and one of the most practical ways to do that is by thinking in terms of preventive, detective, and corrective controls. Preventive controls try to stop a problem before it happens, such as restricting access, requiring approval, or rejecting incomplete input. Detective controls try to discover that something has already gone wrong, such as reviewing logs, reconciling records, or monitoring unusual activity. Corrective controls help the organization respond and restore normal conditions, such as restoring data from backup, reversing an improper transaction, or fixing a configuration error after it is detected. No single category is enough by itself in most important processes. A company may restrict who can change master data, but it still needs review processes in case an authorized person makes a mistake, and it still needs recovery steps if a bad change gets through. Thinking this way helps beginners see that effective control design usually involves a combination of barriers, visibility, and response rather than a single magic safeguard. Another useful design choice involves deciding whether a control should be manual, automated, or a blend of both. Manual controls depend on people to perform reviews, approvals, comparisons, or decisions, and they can be valuable when judgment is needed or when the process changes often. Automated controls use systems to enforce rules consistently, such as limiting input values, blocking duplicate transactions, or preventing unauthorized access without waiting for human review. Each approach has strengths and weaknesses. Manual controls can adapt to nuance but may be slower, more inconsistent, and more vulnerable to distraction or fatigue. Automated controls can be fast and consistent, but they depend on correct configuration, reliable data, and proper change management, because a poorly set automated rule can process bad results at scale. Strong design often combines the two. A system may automatically reject invalid entries, for example, while a supervisor still reviews exceptions to make sure unusual but legitimate cases are handled thoughtfully and that automation is not quietly hiding a deeper problem. In information technology, IT environments, it is also important to understand the difference between broad controls that support the entire environment and specific controls built into individual business processes or applications. Environment-level controls include areas such as access management, change management, backup practices, infrastructure security, and operational oversight. These create the foundation on which more targeted business controls depend. If access management is weak, then even a carefully designed approval process inside an application may be undermined because too many people can alter roles or data behind the scenes. If change management is weak, a previously effective automated rule may be changed without proper review and stop working as intended. Specific process controls, on the other hand, address the details of particular activities such as order entry, payroll, claims handling, inventory movement, or vendor payments. Good control identification pays attention to both layers because organizations often focus heavily on one and neglect the other. A process can be well designed yet still exposed by a weak overall environment, just as a strong environment cannot fully protect a process that lacks appropriate transaction-level checks. Good control design also depends on practical details that are easy to overlook when people think only in broad policy language. A control should have a clearly assigned owner, a defined trigger or schedule, a clear set of steps, and an understood standard for what counts as acceptable or unacceptable. It should also create evidence that it was performed, because a control that leaves no trace is difficult to monitor and difficult to audit. Timeliness matters as well. A review that happens 3 months after a harmful change may be too late to protect the business meaningfully, even if the review is thorough. Exception handling is another design requirement that deserves attention. If a control detects a problem, who investigates it, who approves corrective action, and how quickly should that happen? Weak controls often fail not because the basic idea was bad, but because these practical details were left undefined, leaving people to rely on memory, personal judgment, or last-minute improvisation when a real issue appears. Some of the most important controls in real organizations are built around access, authorization, approval, validation, reconciliation, and separation of duties. The idea behind separation of duties is simple but powerful. One person should not be able to complete all critical parts of a sensitive process alone, when that would create too much opportunity for error or abuse. A person who creates a vendor should not also be able to approve payment changes and release funds without any independent review. In the same way, someone who develops program changes should not be the only person deciding when those changes enter production. Access restrictions help define who can do what. Approvals help ensure important actions are reviewed. Validations help catch incomplete or unreasonable input. And reconciliations help compare one source of truth against another so discrepancies become visible. When these controls are layered together, the process becomes far more resilient. If one safeguard is missed, another may still reveal the issue before serious harm occurs. That layered approach is one of the clearest signs of mature control design. At the same time, good design is not the same thing as designing the maximum possible number of controls. Beginners sometimes assume that more controls automatically mean stronger protection, but too many poorly chosen controls can slow work, confuse employees, create duplicate review, and encourage people to work around the process instead of respecting it. A control should be proportionate to the importance of the activity, the level of risk, and the cost of failure. If a process involves a low-value transaction with little sensitivity, a simpler design may be more appropriate than a heavy chain of approvals that waste time without meaningfully reducing risk. On the other hand, high-risk activities should not be protected with only casual review because someone wanted the process to feel fast. Good control design is really about balance. It aims for enough discipline to reduce meaningful risk while still allowing the business to operate efficiently. The best controls often feel natural to the process they support because they are integrated into the way work should already be done rather than layered on awkwardly as punishment for past mistakes. Another important part of design is thinking about what happens when the ideal control is not possible. Smaller teams, resource limits, legacy systems, or specialized roles can make it difficult to build the perfect separation or the perfect automated safeguard. In those situations, organizations often rely on compensating controls, which are alternative measures intended to reduce the risk to an acceptable level even when the preferred design cannot be fully implemented. If one person must perform multiple tasks in a small office, for example, management may use a more frequent independent review of reports, tighter access logging, or a separate approval step by someone outside the daily process. The key is honesty. The organization should recognize that the original risk still exists and should design the alternative thoughtfully rather than pretending the problem has disappeared. Compensating controls are not excuses for weak practice. They are deliberate adjustments made when practical limits exist, and they still need to be clearly defined, monitored, and evaluated to make sure they provide enough protection to justify the compromise. Control design also has a full life cycle, which means it does not end when a control is first documented or implemented. Controls need to be communicated to the people who perform them, monitored to confirm they are actually happening, tested to see whether they remain effective, and updated when the process, system, staff, or risk environment changes. A validation rule that made sense last year may no longer be strong enough after a new business line is added. A review that worked well when transaction volume was lower may become meaningless if staff now rush through hundreds of items without enough time to notice anomalies. That is why monitoring and continuous evaluation matter so much. Management should ask whether the control is being performed consistently, whether exceptions are handled correctly, whether evidence is retained, and whether the control is still aligned with the current process rather than an older version that no longer exists. Controls that are not revisited can quietly become outdated, and outdated controls can be almost as dangerous as missing ones because they create false confidence. From an audit perspective, control identification and design are important because they reveal how thoughtfully the organization has connected its risks to its safeguards. A certified information systems auditor, CISA, learners should be ready to ask whether the controls match the risk, whether the control objective is clear, whether the design is practical, whether the control is preventive, detective, or corrective in the right place, and whether there is reliable evidence that the control operates as intended. Auditors also pay attention to common design mistakes. A control may rely too heavily on one person, may occur too late to prevent meaningful damage, may lack documentation, may cover only part of the process, or may technically exist while employees routinely bypass it to keep work moving. These weaknesses matter because a control is only valuable when it changes the risk in a real and supportable way. Audit thinking helps sharpen design thinking by forcing the organization to ask not whether a control sounds reasonable, but whether it will truly work under normal conditions, under pressure, and when something starts to go wrong. The main idea should feel much more concrete than it did at the start. Control identification and design are about understanding what the business is trying to accomplish, seeing where risk enters the process, and creating safeguards that are clear, timely, proportionate, and strong enough to support dependable outcomes. The topic matters because organizations do not achieve control by writing broad intentions in policy manuals. They achieve it by placing the right checks in the right places, assigning clear responsibility, creating usable evidence, and adjusting those safeguards as processes and systems change over time. As you continue your studies, keep noticing that strong controls are rarely accidental. They grow from careful observation of objectives, risks, process steps, human behavior, system capability, and business reality. That is why control identification and design sit so close to the center of the CISA mindset. When you understand how to recognize where control is needed and how to shape it well, you are no longer just looking at systems as technology. You are starting to see them as governed business processes that need deliberate protection in order to remain trustworthy.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.